every one of you around. And I'm sure you're as excited as me. Is that correct?
Yes, sir.
All right. Once again, I want to say a very big welcome to each and every one of you. David, you're also welcome.
Sir?
David, David is not here, or he has gone out. Okay,
Mm,
David is one of the students that came into this class, but maybe it's network. He'll be back. All right, you're welcome once again. Can you see what is on my screen right now?
yeah, it's blank.
How about now?
Yes,
All right, Introduction to Organic Chemistry. You're saying it right.
yes.
All right, beautiful. So that is what we're going to be studying today. David, you're welcome back.
Sure.
My pleasure. All right, so let's go into what we have for today. Before we commence, I just want to ask a few questions. Can I go ahead?
Yes, sir.
All right, thank you. First question is, have you ever heard the term organic chemistry before? Organic chemistry, is this something you have heard before, or is it something you are hearing for the first time?
I've heard it, sir.
I've before.
Oh, that's beautiful. So we're dealing with organic chemistry with people who have a basic foundation in the subject. That will make it easier and way simpler to understand. So let me throw the question. When the term organic chemistry is mentioned, what comes to your mind? What rings in your brain? Yes, who wants to go first?
Chemistry, chemistry that deals with the carbon and its compounds.
Okay, okay. How about you, Nadia? Do you have any definition for that? Nadia, are you there? Can you hear me?
Yes, sir. It's the study of carbon compounds
Very good,
and the
very good.
basics of life.
Very good. Thank you very much. That was the word that I wanted you to mention. Carbon containing compounds, and it is the basis of life. Now, you see that word organic. Let me break it down in simpler terms for you. When we say organic, we are simply referring to something that is produced from natural sources. And one of the characteristics of things that are produced from natural sources is that they all contain an essential element called carbon. That is why basically the study of organic chemistry is the study of carbon containing compounds. That is compounds that contain carbon. So let's start off in the introduction this way. Did you know that everything or almost everything around you is made of organic compounds? Are you aware about that?
No.
Yes, sir.
Okay. For those who are not aware, I am informing you today almost everything around you in the world, in your daily activities, are made up of organic compounds. From the air that you breathe to the food that you are going to eat tonight at dinner table, organic chemistry is basically everywhere. Now, here are some examples that you can relate to. If you wore a perfume today, how many of you here use perfumes in this class? Don't lie, oh.
I,
Don't lie, oh. If you use perfumes,
Me,
let me
sir.
know.
I,
Everybody's using perfume now. Nobody wants to say they don't use perfume, Abby. All right. If you use perfumes, did you know that perfumes contain organic compounds? Those are the chemicals that make your favorite scents. When you go to the person that sells perfumes and you're like, okay, let me test each and every one of them, and you're smelling them, I say, oh, I like the way this one is smelling. The reason why you are perceiving that odor and it is pleasant to you is because of organic compounds. All right, the next example is the food and cooking. Everybody here eats food. Is that correct? I don't even need to ask whether that's
yes,
correct. That is correct. The favorite foods that you eat, whether it is carbohydrate-based, proteins, fats, or even spices, each and every one of them contain organic compounds. The third example is plastics and packaging. You're probably watching this lesson, this live lesson on your phone, your mobile device, or a laptop. Whichever one you are using, they all contain plastic. And you see that plastic, it is made of organic compounds. And even the medicines and drugs you take when you are unwell or ill, they contain organic compounds as well. And then here is my favorite example, gasoline, which is also known as the petrol that you buy at the filling station, diesel, and natural gas, which is the gas that is in your gas cylinder. All of them contain organic compounds. So you can see all the examples that I gave shows that organic chemistry applies to our daily lives. We're following.
Yes, sir.
Yes, sir.
So here are some points on the screen. Nadia, I want you to read what you can see right now.
Okay. Organic chemistry touches every part of life.
That's correct.
Ever okay. Ever enjoy the scent of vanilla?
Do you know what
That's
vanilla
an
is?
organic compound. Yes, sir.
Okay, very good. That's an organic
Mhm.
compound. Oh yeah, continue.
The plastic in your water bottle,
Mm-hmm.
also organic.
Mm-hmm.
Even the medicine that cures a headache is built on organic chemistry.
Is built on organic chemistry. So let's go ahead and define what organic chemistry is. And I'm very happy you all made it easy for me. You broke it down, so that gave us a platform for us to build on. Organic chemistry is a branch of chemistry. Now, um, in the first class in this free series of chemistry classes where I was teaching SS1. We're talking about the various branches of chemistry. We talked about plenty of them. We talked about the physical chemistry, inorganic chemistry, biochemistry, and so many other branches. One of those main branches of chemistry is the organic chemistry. It is a branch of chemistry that focuses on the structure. Take note of the words that I'm using. The properties and the reactions of molecules that contain carbon. So, as far as organic chemistry is concerned, the superstar, permit me to use that word, the superstar or the element that takes the center stage is the element known as carbon. Are you with me on this one?
Yes.
I'm so glad you're following. Nadia, can you hear me clearly?
Yes, sir.
Okay. Now, carbon is unique because it is able to form strong bonds with itself and with other elements. And because of that, that is why it is able to form a vast diversity of organic compounds. So here is what makes carbon very special. It is able to form strong bonds both with itself and with other elements. This ability now allows carbon to be able to produce plenty different types of organic compounds that affect our day-to-day lives. So now here are some key concepts about organic compounds. The first one that is on the screen, David, I want you to read it. What can you see on the screen right now?
Key concepts about organic compounds
Mm-hmm.
involves carbon and hydrogen, bracket C to H bonds.
Okay.
Organic molecules must contain carbon and often bond with hydrogen. Many organic compounds also contain oxygen, nitrogen, sulfur, and phosphorus. For example, protein and DNA. Found in nature and man-made materials. Organic compounds exist naturally in living organisms, e.g., glucose in fruits. They are also synthesized in laboratories, e.g., Plastics, dyes, and medicine. Hello, hello.
Can you hear me now?
Can you hear?
Hello, David, can you hear me?
Hello.
Hello, David, can you hear me?
Yes, sir. Yes, sir.
How about you, Nadia? Can you hear me now?
Yes, sir.
Okay, beautiful. So let's move on to the notes for today's class. I shared a note into the um uh SS3 class. Were you able to download it?
So I did
Hel-
the books.
No, 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 the notes for today's class. Can you see what's on my screen right now?
Yes, sir.
Okay. What's on the screen? What can you see on the screen right now?
Key concepts about carbon, but it's not bold enough.
Okay. Okay. Maybe it's sharing the wrong thing. I want to share my screen to the notes. Hold on. Good. Can you see it now?
Yes, sir.
Good. So these are the notes for today's class. Were you able to download this? Nadia, I sent it to the group. Did you download it?
Yes, sir.
All right,
Yes,
very good.
I said.
All right, very good. So this is what we're going to be studying today. So let's move on to the scope and the importance of organic chemistry. This is what we're talking about right now. So I want you to read the first point, Nadia, and then David will read the second point. And then I'll take the third one and the fourth one,
Okay.
and then we'll proceed from there. Yeah, you go first,
Okay,
Nadia.
sir. Organic scope and importance.
Mm-hmm,
Organic chemistry is central to understanding life processes,
mm-hmm,
since all living organisms are built from organic molecules, such
mm-hmm.
as proteins, carbohydrates, lipids, and nucleic acids.
Nucleic acid. Thank you very much. I'm going to explain what all of that means, okay? David, you read the second point.
Okay. It has wide applications in medicines, agriculture,
Mm-hmm.
food, energy, textiles, and petrochemical industries.
Beautiful, beautiful. Now, the third one, organic compounds form the basis of fuels, plastics, dyes, detergents, and drugs that are essential for modern lives. It also provides a framework for developing new materials and understanding biochemical compounds. Now that we know what organic chemistry is and what the central element in organic chemistry is as well, let's talk about the sources of organic compounds. Now, in organic chemistry, there are two basic sources of organic compounds as far as the concept is concerned. The first one is called the natural source, and the second one is called the artificial. Some people like to call it the man-made. Well, whichever one you choose to call it, whether artificial or man-made, it is absolutely up to you. Are you with me on this one?
Yes, sir.
Can you
Yes,
hear
sir.
me? Can you hear me
Yes,
Yes,
sir.
clearly?
sir.
All right. Is the class boring?
No,
No.
sir.
All right, good. So from natural sources, I have three examples that can serve as the sources of organic compounds. Example number one are the ones that you all know, plants. Plants are the most abundant source of organic compounds on earth today because they are the ones that provide materials that contain carbohydrates. Now, David, can you tell me the sources from where we get sugar from? Where do we get sugar from? What plant produces sugar? There's a plant that produces sugar. Can you tell me what that plant is?
Oh, I don't know.
How about you, Nadia? Do you want to try?
Sugar cane.
Thank you very much. Very
Sure.
correct. Sugarcane. Did you know that sugar is gotten from sugarcane?
Sir?
No.
Dave, did you know that sugar is gotten from sugarcane?
No.
Okay, you are knowing now. One of the plants that we get, or the source of sugar, the plants we get it from is called sugarcane. All right, now, apart from sugar, starch and cellulose, all of them are produced from plants. Now, have you ever been sick and then instead of taking you to the doctor, maybe your mom says, "Oh, let's make agbo." How many of you know what they call agbo?
Me, sir.
Me.
Very good. Agbo. What is agbo?
Medicine.
It's herbs,
Natural medicine.
leaves
Thank
that
you.
they gather.
Yes, thank you. That was the word I was expecting to mention. Leaves that they gathered. Now you would notice something. When they gather those leaves together, they will put them in water and then boil it. Am I correct?
Yes,
Yes,
sir.
sir.
When they boil it, after some time, the color of that water will change, and then they pour it out for you to drink it. Is it sweet or bitter?
Bitter.
Very, very bitter. Now, the bitter part is not where I want you to place your mind on. Those
Yeah.
plants contain what they call organic compounds, and they are the sources of it. So that's the first natural source. The second natural source of organic compounds that we have are animals. Okay? Animals, through their flesh or the meat that we eat, they supply proteins. Nadia, what is your favorite meat or your favorite protein?
Mm, chicken.
Chicken. How about you, David?
Same.
Same here, chicken, okay? So whether it's chicken, fish, beef, whatever it is, they are all gotten from animals and they supply fats, vitamins, and natural products like wool, silk, and hormones. What animal do we get wool from?
Sheep.
Thank you very much,
Sheep.
sheep. I'm so excited that you're following every bit of today's class, David and Nadia. And then finally, the final example of natural sources of organic compounds are the fossil fuels. Now, before I even talk on this, I want to ask you a question. What is a fossil fuel? Who wants to answer that
Uh,
question? What are fossil fuels?
Animals
oh,
that have died and long decay that are buried in the
and
ground.
decay.
Hmm. You are close, Nadia, but there was something you mentioned that you were not supposed to mention. But you're very close. You're very close. That I must say. You're very close. How about you, David? Do you want to try?
Animals that have died and their body has decayed, then it's used as fuel.
Okay. Now, it is not just animals that have died. It is also including plants that have died. Fossil fuels are the materials that are gotten from the decomposition of plants and animals over a long period of time. Now, when my chemistry teacher, when I was in secondary school, was teaching me, he made me understand this concept that when animals and plants die, they begin to decompose into the soil. After a while, they are buried underneath the soil surface. And then something begins to happen. Heat and pressure begins to be applied on them because under the ground is hot, number one, and then the weight of the earth above them begins to apply pressure. Now, do you know what happens after a while? That application of heat and pressure begins to transform them from what they used to be into something called fossil fuels. Now, those fossil fuels are what we now know as petroleum, natural gas, and the rest of them. In fact, when we combine all of them together, we get all something that is called, have you ever heard this word before?
Yes, sir.
Okay,
Yes, sir.
what did I write?
Crude oil.
Crude oil,
Good. Where is crude oil gotten from?
the ground,
Thank
Cause
you.
underground.
ground.
It's gotten from underneath the ground. Now, why is it gotten from underneath the ground? It's gotten from underneath the ground because when plants and animals die and decompose, they go under the ground to undergo the transformation that converts them into crude oil. I'm so glad you're following through with today's class. And then the next source of organic compounds that we have are the synthetic or the artificial or the
Mm-hmm.
example number one. Can you read it for me, David? Under the artificial sources of organic compounds.
laboratory productions,
Thank you very much.
organic compounds like urea,
Urea.
ethanol, urea,
Urea.
ethanol,
Say urea.
urea.
Urea, yes. And Nadia, do you know how to pronounce it?
Yes.
Urea.
Urea. Thank you very much. That's how it's pronounced. Urea. All right, go ahead. Go ahead.
Ethanol,
Mm-hmm.
aspirin,
Aspirin.
and dyes.
Do you know aspirin?
Is a drug.
Yes, correct. It's a drug. And even dyes. All of them can be
Can be synthetic
synthesized in the
in the lab.
laboratory. All these ones that I just mentioned, they are not necessarily gotten from living organisms like plants and animals. They are produced by man in the laboratory. Example number two are the ones you know as petrochemicals. Crude oil, when it is gotten from the ground, it is now refined in refineries or industries that undergo refining processes. Now, through a process like fractional distillation, have you ever heard that word before? Fractional
Yes,
distillation.
sir.
Thank you
Yes,
very
sir.
much. Good. Do you know what it means?
Mm,
It's separation of two different something.
Okay. All right. Let me break it down for you. Fractional distillation is actually the combination of two words, fractional and distillation. It is a separation process that is used to break down or to separate crude oil into its various components. Now, that is what they do in refineries, enabling them to produce things like gasoline. You know, gasoline is the petrol that you use in your generator and your car, right?
yes,
Yes,
sir.
sir.
Very good. Gasoline, kerosene, and even diesel. And that serves as a major source of organic feedstock. And then final example, Nadia, I want you to read it.
Polymers.
Mm-hmm,
Man-made materials such as plastic,
mm-hmm,
bracket open, PVC,
mm-hmm,
nylon,
mm-hmm,
polythene, bracket
mm-hmm.
close, synthetic rubber, and synthetic fibers are produced industrially.
Very good. Do you know what a polymer is? Let me throw the question to the class.
No.
Okay. How
No,
about you, Nadia?
I've forgotten.
You've forgotten. Okay, let me remind you and refresh your memory. Now, polymer is simply the combination of two words. Poly and then ma. Do you know the meaning of when they say poly? Do you know what it means?
No,
David, how about you? Do you know what it means?
No.
Okay, when they say poly, they simply mean multiple or
Oh.
plenty. Have you ever heard this word before? Mono.
yes,
Yes,
sir.
sir.
Good. What does it mean?
One.
Thank you.
One.
One or single. Now, a polymer is simply something that is produced when you have plenty units joined together. This other word here, MER, it represents or it means one unit. So when we say polymer, we are simply talking about multiple or plenty units. Can you see what I'm writing on the screen?
Yes, sir.
So it's just like a chain, for instance. You all know what a chain is. You have one small link joined to another small link like this. Then that small link joins to another small link. 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 Is that not so?
Yes, sir.
Yes. So this can be an example of what a polymer is. You have one small unit joining with another small unit, joining with another small unit, joining with another small unit to make something that is very big. Now, bringing that down to chemistry, a polymer is simply the product of many single units being joined together. And a very good example of polymers that you have are your plastics. All of you can give me an example
Oh,
of what a plastic is, right? Give me an example of a plastic.
sure. Don't hear you.
How about now? Can you hear me now?
Oh, I can't hear you.
How about now? Can you hear me now?
Yes, sir.
How about you, Nadia? Can you hear me now?
Yes, sir.
Okay, beautiful. I said, can you give me an example of plastics? Plastic that you know.
Rubber.
Okay, rubber. How about you, David?
What? Uh, some bottles.
Okay, bottles, the plastic bottles that you use for drinking water. Now, those are very good examples of polymers that we have. So, in summary, what we're saying basically is organic compounds come from both natural and artificial sources, nature and human sources. While natural sources have been used since ancient times, the plants, the animals, all of them, they have existed even before our forefathers. The modern sources or the artificial sources are produced in our modern lives, and they depend heavily on synthetic organic materials like fuels, plastics, and medicines. Does anybody have any question at this point? Is there any confusion?
No,
Are
No,
you sure?
sir.
Are you sure?
no, sir.
All right, then let's talk about the characteristics of organic compounds. So, first of all, organic compounds share unique features. Okay, those unique features distinguish them from inorganic compounds. And these properties are as follows. Number one, David, I want you to read it for me.
Low melting and boiling point.
Very good. Now, you gave me an example of one organic compound that you know, and you said plastic.
Yes, sir.
Is that correct?
Yes, sir.
Good. Is it easy for plastic to melt when you place it in the fire?
Yes, sir.
Very good. In other words, the boiling or the melting point, because melting is when something changes from solid to liquid. The melting point of plastic is low. Most organic compounds have relatively low melting and boiling points when you combine or when you compare them to inorganic salts and inorganic compounds. Why is that? It is because they are mainly held together by weak intermolecular forces. Now, here is a very good example. If you pick plastic, for instance, or a shirt, you would agree with me that there are shirts that if you want to tear them, it doesn't take you much strength. Once you just hold the shirts in between your two hands and you separate your hand like this, it is already torn. Is that correct, Nadia? Is that correct, David?
Yes, sir.
Sir.
Very good. Now that is a proof that the intermolecular forces that holds the particles together are very, very weak. As such, most organic compounds have low melting and boiling points. I want you to read the second characteristic, Nadia.
So, covalent bonding nature.
Good.
Organic, organic compounds are primarily made up of
Primarily.
covalent bonds.
Mm-hmm,
Primarily
mm-hmm,
made up of covalent bonds between
mm-hmm,
carbon and other atoms. Bracket
mm-hmm.
open. Hydrogen, oxygen, nitrogen,
Thank you
etc.
very much. I was so excited. I was expecting you to say maybe H, O, and N, but you mentioned them completely. That's very good. Now, if you notice something, we said covalent bonding nature. Do you know what a covalent bond is? Covalent. Do you know
Yes,
what
sir.
covalent is? Yes, what is covalent?
It's when they share electrons.
Very good. When they share electrons, a covalent bond is a bond formed when atoms share electrons. And that is why, as we proceed in this series of organic chemistry, we're going to be learning how to name organic compounds. When we get to the point of naming organic compounds, you will see examples like, you see something like this. You see where you have carbon joining to carbon, joining to carbon, joining to carbon, and then you'll be seeing things like this. Have you ever seen something like this before?
Yes, sir.
Very good. How
Yes,
about
sir.
you, Nadia? Have you seen something like this before?
Yes, sir.
Yes. Now, all these lines that you see me labeling right now, they are all covalent bonds because the electrons are being shared between carbon over here and carbon over here. So that is one very big characteristics of organic compounds. They share bonds or they share electrons between each other, which brings us back to their covalent bonding nature. Organic compounds are primarily made up of covalent bonds. This bond makes them less conducive or less conductive to electricity since covalent bond lack free ions. So point number three is the solubility. Usually, organic compounds are insoluble in water. One of the examples of organic compounds that you gave to me was plastic. Now, I want to ask, if I put plastic inside water, is it going to dissolve?
No, sir.
How about you, David? Is it going to dissolve?
No, sir.
Of course not. Plastic is not going to dissolve if I place it in water. That is just one example of the many, many organic compounds that we have. So most organic compounds do not dissolve in water because they are non-polar and water is polar. And like dissolves. Like when it comes to dissolving, when it comes to the issue of dissolving something, it is like that dissolves like. And because organic compounds are non-polar and water is polar, it is not able to dissolve it. And then the next example is this. I want you to read it, Nadia. This one that I just labeled. Can you read it for me?
Hello.
Hello, Nadia, can you hear me?
I can.
Yes, sir.
Hello.
Sorry.
Yes.
Soluble in organic solvents.
Mm-hmm.
They dissolve easily in non-polar solvents such as benzene, ether, or chloroform.
Chloroform. Thank you very much. David, you were stating that you couldn't hear me clearly earlier on. Can you hear me now?
Yes, sir.
All right, very good. I think the network is fluctuating a bit, but we'll soon be done. Here is a very good example. Oil does not mix with water, but it dissolves in kerosene. And then the next example, I'll take that myself, is flammability. Now, organic compounds are generally very flammable. Flammable means when you place them in fire, they will be ignited. Now, one of the good examples of organic compounds, we stated earlier on that they are fuels or the petroleum that we produce from crude oil. Now, I want to ask, is petroleum flammable or not?
It's flammable.
If you had said no,
Flammable.
if you had said no, I would just say let's close today's class. There's no point continuing. Very good. Petroleum is flammable, and that is one very good example of the organic compounds that we have. For example, petrol burns with a bright flame producing heat energy. And then this last one, I like this one very well, the formation of homologous series. We're going to be going deeper into this one when we get to the part of naming organic compounds. You see where we talk about stuff like alkanes, alkenes, and alkynes. Okay? So just for now, notice that organic compounds usually exist in families. Those families are what we call the homologous series. So when they say homologous series, what is it? You simply say it is the combination of the families that organic compounds exist in. So right about now, we're moving into the application of organic chemistry. What are some of the applications of organic chemistry that we have? I want you to read one. David, you read the first one, and then Nadia, you read the second one, and we'll proceed like that.
Okay. Medicines and pharmaceuticals.
Pharmaceuticals, correct.
Organic chemistry provides the foundation for the development of drugs and medicines. Compounds such as aspirin, antibiotics, and vaccines are products of organic synthesis.
Mm-hmm,
These drugs help in treating illness,
mm-hmm,
preventing disease,
mm-hmm,
and improving overall health.
mm-hmm. Thank you very much. Thank you very much. So, David, I want you to be the teacher for one moment. This thing you just read, can you tell me what you understood from it?
Uh, Organic chemistry is
Mm-hmm.
what we use in making drugs
Very
for
good.
improving health.
Mm-hmm. 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 Thank you very
So,
much.
uh,
Thank you very much. All right, Nadia, you're up now. I want you to read the second example.
Food and nutrition.
Mm-hmm.
Organic compounds such as carbohydrates, proteins, fats, vitamins, and enzymes are essential for human nutrition. Food additives, preservatives, flavoring, and coloring, and are also designed using organic chemistry to improve the quality, taste, and shelf life of food.
Very good. Very, very good. Now I'll read the third example. These are some of the applications of organic chemistry, by the way. So example number
Okay.
three. Yes, example number three are fuels and energy. Organic chemistry helps us to produce stuff from fossil fuels. Those stuffs like petroleum, coal, and natural gas, they are mainly composed of organic
That's
compounds.
waiting.
Hello, are we together?
Yes, sir.
yes, sir.
All right. Now, those fuels serves as the primary energy source for industries, transportation, and even domestic use. Can you tell me the fuel that we use domestic in our domestic homes? Can you tell me the name of the fuel that we use in our domestic houses?
Petroleum.
No.
Well,
Well, we use petroleum in our house, but there is one that we use when we want to cook, we use it.
gas.
I know it's I know it's gas.
I don't
When
know.
you go, when you go with your gas cylinder you want to buy, you say, I want to buy gas. Yes, I know they call it gas, but what is the name?
Hmm.
Nadia, do you want to try?
Sir?
Do you want to try? What is the name of that gas that we use in our homes when we want to cook?
Yeah, I don't know.
Okay, it's an assignment now. I want you guys to go and make a research. You can use the internet, whatever it is, to broaden your horizons. The gas that we use in our homes for our domestic cooking, what is the actual name? They call it gas, but there is a name for it. I want you to go and find that out. Can you do that for me?
Yes, sir.
Yes, sir.
All right, beautiful. So next example or next application of organic compounds are the plastics and polymers. Organic chemistry is central to the production of plastics. Plastics like synthetic fibers, rubbers, materials like nylon, polyester, PVC, and so many more. They are widely used in clothing, packaging household items, and even in construction. And then we have two more, cosmetics and personal care. Now, I want Nadia to read it because she's the lady among us and they will know so much about these cosmetics. Is that true?
Yes, sir.
Oh, yeah, read it.
Cosmetics and personal care. Perfumes, soaps, shampoos, lotions, and makeup products are manufactured from organic compounds.
Good.
These compounds provide fragrance, cleansing, and preservation functions, enhancing personal hygiene and lifestyle.
Beautiful. 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 So you see those perfumes that you use when you wake up in the morning, take your bath, and you're preparing to go out, maybe to school or wherever you're going to, the perfumes you use, the soaps you use when you're taking your bath, the lotions, all those things that constitute your cosmetics and personal care items, they are all containing organic compounds. And then the final one, which happens to be my favorite because my mom happens to be a farmer too, is agriculture. David, can you read this for us?
Okay.
Mm-hmm.
Organic chemistry contributes to the creation of fertilizers,
That's good.
pesticides,
Mm-hmm.
herbicides,
Mm-hmm.
and insecticides that improve crop yield and protect plants from pests and diseases.
Beautiful. Now, I want to um, give some activities. Can you define what a fertilizer is? Can you define what a pesticide is? Can you define what an herbicide is? And then can you define what an insecticide is? Which one can you define among them?
Uh,
Fertilizers, herbicides, and
fertilizer.
Okay,
insecticides.
define the fertilizer.
Okay, fertilizer are those chemicals that we spray in crops or plants to make it to grow and
Okay.
enhance it.
I
Then
like
it will not like it will grow well.
it will grow well, I know. All right. Fertilizers are chemical substances, correct? Chemical substances that are used to enhance the yield of crops. Are you there?
Yes, sir.
All right, how about pesticides? What is a pesticide?
It's a chemical that is used to kill pests to
Very
make
good.
crop growth way
Very
faster.
good. To kill pests. Nadia, do you know what a pest is?
Yes, sir.
Okay, can you give me one example?
Caterpillar.
Caterpillar, very good. Now, the thing is, when farmers plant their crops, depending on the kind of crops that they plant, there are certain animals that usually come to spoil what they plant. Those animals are called pests. And that is why organic chemistry has a very good application in agriculture. Through organic chemistry, we are able to produce chemical substances that are known as pesticides. When these chemical substances are applied on the farm, they kill these organisms, thereby making those plants to be able to produce more. And that brings us to the third one, herbicides. Herbicides, who wants to define it, or should I go ahead?
Go ahead.
Go ahead, please.
All right, all right, all right. I will go ahead. Herbicides, like the word says, is the combination of two words, herb and then side. Herbicide is a chemical substance that is used to eliminate the presence of unwanted plants. Now, I stay in the north in Nigeria basically, and during the rainy season,
Okay.
we are currently in the
Okay,
raining
sir.
season. We are currently in the raining season.
Okay, sir.
And when is the raining season, we used to plant there's this thing we call gero and corn, we call it maize and all of that. When we plant them, after a while, when they begin to grow, you'll see other grasses around that will begin to grow with them. And if care is not taken, those grasses will make the nutrients that are available in the soil not to be able to go around. Are you with me? Have I lost
Mm.
you?
Yes, sir.
Okay, good. Those grasses,
Yes, sir. Okay.
there is a particular name that we give to those plants that are growing in a place where they do not want them to grow. What is that name?
Weeds.
Thank you very
Weed.
much. Thank you very much. Weed is not the one that bad people used to smoke, oh, please. I'm talking about the plants that are growing in a place where they are not wanted. Okay, so when plants are growing in a place where they are not wanted, the chemical substances that we use to eliminate their presence, they are called herbicides. And then finally, this one, everybody must know it because of mosquitoes, insecticides. Am I correct?
Yes,
Yes,
sir.
sir.
Yeah, it is because of organic chemistry that we are able to produce insecticides. Now, what is an insecticide? Who wants to try?
An
Please.
insecticide.
Okay.
Yes, go ahead. Whoever is trying should go ahead. I'm here to learn from you. What's an insecticide?
Okay. An insecticide is a
Mm-hmm.
chemical used to kill insects.
Thank you. As the word says, insecticide. So it is used to kill insects. And we have different types in today's world. There are different brands of them. So basically, we have seen how organic chemistry applies to our daily lives. We've seen the applications of it in agriculture, in the food industry, in personal care and cosmetics industry. Basically, organic chemistry has something to offer in every aspect of our life. So I have some assignments for you that I want you to go back home and do for me because we've come to the end of today's class. Nadia, can you see what's on the screen?
Yes, sir.
All right. Um, Here are the things that I want you to do. Okay. I'm going to be dropping the link to submit this assignment. Okay. You do that, and then
Okay.
in the next class, which is on Saturday by 10 a.m., we're going to be going into the concept of naming hydrocarbons. That thing that I was drawing for you like this, we're going to be seeing how to name them. Are you excited about that?
Yes, sir.
Yes,
All
sir.
right, so these are your assignments. In your own words, define organic chemistry. Mention two natural sources of organic compounds and give one example of each. Then list two synthetic or industrial sources of organic compounds. And then the remaining ones, state three general characteristics, mention two applications, and then write short notes on the importance of organic chemistry in medicine and fuels. Don't worry, you won't need to use your notes to write them, okay? I will drop the link where you can submit the assignments, and then I will see them
Okay,
when you
sir.
submit them. Are we good?
Yes, sir.
All right,
Yes, sir.
for today's lesson, does anyone have any questions to ask? Is there anything that confused you?
No.
Okay, beautiful, beautiful. So we've come to the end of today's lesson. I want to thank you for sticking around till the end. I'm looking forward to seeing you on Saturday. Until then, my name is David, and I'm your favorite digital chemistry tutor. Bye bye.
Bye, sir.
Bye.